Hi, my name is Jack Billings, and I'm a Z software technical specialist with IBM focused on Z DevOps. And in this video, I'm going to talk about leveraging Jenkins with ZOS Connect REST APIs. I'm going to briefly touch on how ZOS Connect works and how it's used, but I'm not going to get too technical about ZOS Connect, but instead I'm going to focus more on the next step of how you can use Jenkins Pipeline with your ZOS Connect artifacts to facilitate changes to your REST APIs. So those of you that already have REST APIs or those of you that plan to create some with ZOS Connect, it's important to think about how you're going to create, deploy, and test those REST APIs in a consistent way. You also want to have a strategy on how to store and organize your ZOS Connect artifacts. And then lastly, how you can integrate them with some of your other DevOps processes. So in this video, I'm going to go through sort of a half presentation, half demo to show you why having a pipeline in place will be important as you start creating and editing REST APIs with ZOS Connect. So for this presentation slash demo, I want to lay out a little context to begin. I'm going to assume the role of an application developer that already has my ZOS Connect API deployed and running properly. The Jenkins pipeline I'll eventually show can also be used to create new services and APIs. But in this scenario, I'm just using the pipeline to update my API when a change is made to the backend program that it accesses. Also, I'd like to point out that this pipeline can build APIs for WOLA, IMS, and REST client service providers, but in this scenario, I'm just building them for a CICS service provider. Alright, so like I said, I'm assuming the role of an application developer, and I've created this simple front-end Node.js application that shows office supply items, and you can see a description, cost, and quantity in stock of each item. And that data, description, cost, and quantity in stock, isn't hard-coded in, but comes from a CICS COBOL application that is API enabled with ZOS Connect. So ZOS Connect lets me create an API from a backend CICS COBOL application, and that API can then be invoked RESTfully to retrieve mainframe application data that is used in this Node.js app. So we can look at the CICS app that we're accessing and see that we have the same data. So we have ball pens blue 24 pack as a description that costs $2.90 in this CICS application and also in this Node.js application. So where is the data for both applications defined? The data resides in a vsam file, which we read and update through a COBOL application. And the COBOL copybook here contains the source code that defines the fields that are used by the COBOL and CICS applications, and then also the ZOS Connect REST API that this Node.js app uses. So we have a description field, a cost field, and an in-stock field in this COBOL copybook. If we look back in our CICS application, we have the description field and cost field. And then over in our Node.js app, we have the description, cost, and also takes advantage of that in-stock field. Alright, so that's how this Node.js app gets its data from a backend CICS COBOL application that is API enabled with ZOS Connect. And as an application developer, I can easily make changes to my Node.js code here. But when I want to make changes to the COBOL copybook that ZOS Connect uses to create the REST API that is then consumed by this Node.js app, it can be a fairly long and tedious process. because I need to make a lot of manual changes and run some manual tests. So I'm going to go through all the manual steps I currently have to take to recreate, redeploy, and retest the ZOS Connect services and APIs whenever I make a change to the copybook that they read from. So first, using some IDE, I'll have to add or remove fields I want in my COBOL copybook. And since I'm using a source code manager to store and organize my ZOS Connect artifacts, including my copybooks, I'll then have to take those artifacts from my SEM and manually update the copybook on my ZOS system. Then I'll need to rebuild my COBOL program that uses the copybook I just changed. Next, I'll have to redefine the request and response service interfaces with the updated copybook. The service interfaces define what fields to expose and how they're exposed in the service. So in our case, it's exposing the fields in the copybook you just saw. I'll then have to manually export my service archive files to a folder and deploy those files to my ZOS Connect server. The service interface definitions are used by the service archive files to do the mapping / translation from JSON to whatever backend subsystem you're trying to access. So in this scenario, a CICS COM area. Basically, the ZOS Connect service provider is the connection point to the CICS COM area and uses the service archive files to communicate back and forth. These service archive files are then used by the ZOS Connect REST APIs to communicate with the backend subsystems. So I don't want to get too technical with it, but that's sort of a little summary on how ZOS Connect services work and how they access backend subsystems. All right, next, I'll have to manually test that my services are on the ZOS Connect server and are working properly. I'll then have to start creating my API in IBM Developer for Z using the API toolkit, which means I'll first have to reselect the service archive file I just changed for my API to then use. And then I'll have to do the API request and response mapping with the API toolkit, which is just defining how you'll send a request to the API and what the response looks like back from the API. Next, I'll have to update and save that API configuration. Then I'll have to deploy the API to my ZOS Connect server. I'll then have to manually test that the API is on the server and that it's working correctly. And then I'll need to push all those files back up to my source code manager. And then finally, I'll need to rebuild and redeploy my application once I've made changes to the API consumes. So all in all, there are 15 steps I have to take to recreate, redeploy, and retest my ZOS Connect services and APIs whenever I make a change to the COBOL copybook that they use. But with a pipeline in place, we can automate most of that process so that I only have 5 manual steps that I need to take when I make a change to a copybook. So first, I'll still need to use an IDE to make my code changes. I could use an Eclipse-based or VS Code IDE to make those changes. But then I'll need to use the API toolkit in IDZ to select the change ZOS Connect service that my REST API uses and do some API request and response mappings. And then finally push those change files back up to my source code manager. But the rest of the process that I went through on the previous slide will be automated, which ends up saving me a lot of time and also keeps my process consistent because it goes through the same structured steps each time. And I'm going to actually go through and show you these steps in a few minutes when I go through the demo. But before I get there to my demo, I want to give you a quick overview of the tools you'll see in my environment. So first, I'm using GitHub, which manages version control using Git as my source code manager to store and organize all my files. GitHub is the most popular open source Git repository manager, so that's why I used it, but there are other tools like GitLab and Bitbucket that work with Git that you can also use. Another tool I'm using is an OpenShift cluster that has a Jenkins server and the Node.js application I showed earlier called eGUI, both deployed as containers in it. So Jenkins is a free and open source pipeline orchestrator that I'm using to automate this process. It takes the files and code from my GitHub repo and then reads a script called a Jenkins file, which has all the defined steps to take for the creation, deployment, and testing of the ZOS Connect services and API. And it will also deploy the Node.js eGUI application. And I'll show you a snippet of one of my Jenkins files a little later to give you an idea of what it looks like. Next, the IDE I'm using for code changes is IBM Developer for Z. I also have to use the API toolkit in IDZ for the ZOS Connect API request and response mappings. And then I use the eGit plugin to communicate with GitHub to push and pull files to and from IDZ. And then for my ZOS environment, I'm using Z Development and Test, which runs ZOS on x86 hardware. So I can have my test ZOS environment right here on my laptop. And that's actually what you saw earlier when I showed the Kix application and the COBOL copybook. Comes with Z software that includes ZOS and middleware like Kix, and that's where I'm running my COBOL app and my Kix app. And that's also where I'm hosting my ZOS Connect server, which has two services called Inquire Catalog and Inquire Single. Inquire Catalog is for the listing of office supply items that you saw earlier in my Node.js and Kix apps, and Inquire Single is to get the specifics for each of those office supply items. It also has the API called Catalog, which uses those two services and is invoked RESTfully by my Node.js app to access the Kix data. So if you follow the arrows, Jenkins deploys the services and API to the ZOS Connect server, which are then consumed by the Node.js eGUI app. All right. And lastly, I'm using dependency-based build, or DBB, which integrates with Jenkins to automate adding my copybooks from GitHub to my PDS members in ZOS, and also rebuilding my COBOL program. The DBB gives some automation capabilities based on a scripting language called Groovy that can be used on ZOS to build COBOL, PL1, and other types of programs. It uses Java APIs that allow you to run MVS, TSO, JSL, and some other types of commands. And in my case, I'll be running a command to transfer the changed COBOL copybooks from HFS to a PDS member, and also an MVS command to rebuild my COBOL application once a change has been made to the copybook it's using. So how it works with Jenkins is that within Jenkins, I defined an agent that is configured to run in USS on my ZD&T system. And that agent uses a Rocket Git port on ZOS to pull down my GitHub repo, then run those DBB and Groovy scripts in there. And again, I'll explain in more detail how that all works once I get to that step in the pipeline. So that's the environment setup I have. GitHub is my source code manager. OpenShift is running my Node.js app. and the pipeline orchestrator Jenkins. IDZ is my IDE and is used to do API mapping. DBB automates adding copybooks to PDS members and rebuilding my COBOL program. And ZD&T contains my ZOS environment that includes the Kix COBOL application and the ZOS Connect server. And you'll see all of these tools as I go through the demo in a bit. Okay, so now that you have an overview of the environment, let me start by looking at my GitHub repository that stores and organizes all the code and files I need for my Jenkins pipeline. So we look in the archives folder. I have two service archive files defined, which again are the mapping / translation from JSON to whatever backend subsystem you're trying to access, which for this scenario is Kix. So first we have the inquire catalog service archive file, which represents the information about a list of office supply items. This is a service that was used to list the office supply items you saw in the Node.js and Kix apps earlier. And I also have an inquire single service archive file, which represents the information about each specific office supply item. Back in the catalog folder, I have the API archive file called catalog, which is a file that describes the configuration of the API and the HTTP methods on how those services can be called. Basically, this file defines how we can send requests to the catalog API and how it will respond. Right. In this folder, the dependency-based build folder, we have these Groovy scripts and configuration files to automatically place my copybooks in the right PDS members and also rebuild my COBOL program. So I have a Rocket Git for ZOS port running that will pull down this GitHub repo to ZOS, then run my Groovy scripts to add the change copybooks to the correct PDS members, and then also rebuild the COBOL application that uses those copybooks. This folder also has all the copybooks that the Kix COBOL application and the ZOS Connect services and APIs uses. This is the copybook that we looked at earlier with the description, cost, and in-stock fields. All right, go back. Repository also contains the ZOS Connect build toolkit, which is the command line tool, and SDK, which reads property files, then creates those archive files you saw earlier, the acquire single service archive file, acquire catalog service archive file, and the catalog API archive file. So if we look in properties, these are the properties files that create them, the archive files. So we have defined some fields. It's a Kix provider, the name of the service is inquire catalog, the version number. This is the COBOL program that uses these copybooks. The program interface is a COM area, and then the request and response structure is based on that copybook that we just looked at. All right. I also have this test folder with the output from the test the pipeline will run against the services and API. And then finally, I have these Jenkins files, one for the API and one for the services. The Jenkins files are scripts that define the pipeline that I'll be running. It contains all the steps for the recreation, redeployment, and retesting of the services and API. So if we look in the Jenkins file to create the services, we can see that this node runs in ZOS, and it'll pull down this GitHub repo into HFS, and then it will update the copybooks to the correct PDS members using simple Groovy script along with some DBB commands. And then it will also run this script that rebuilds the catalog COBOL program automatically. And then on this node is running an OpenShift, and again it'll pull down this GitHub repo. And this is the step that creates the service archive files. So it uses the ZOS Connect build toolkit, looks at the properties files, and then creates the Inquire catalog and Inquire single service archive files based on the properties files. Alright, so that's the repository. I'd like to also add that we're currently working on a series of code patterns and tutorials centered on bringing DevOps practices to ZOS Connect projects. And one part of the series is on some best practices for organizing your ZOS Connect projects in a Git repo and how to use Git to manage changes to your projects. So that'll help with the transition of moving projects into a Git repo and organizing existing projects that are already in one. Now, overall, just a helpful way to get started with ZOS Connect projects in Git based on some best practices that we found. Alright, so now that you've seen the repository, let's start in IDZ and take a look at a COBOL copybook that I'll be changing. Since some of these steps take some time to run and I don't want to waste time sitting here watching something run, I've pre-recorded some things so I can speed past them a bit. So here in IDZ, I've used the eGit plugin to clone my GitHub repo you just saw. We'll look at the copybook that is used to create the ZOS Connect service Inquire single, which has detailed information about each office supply item. Let me go back. So here you can see the description, cost, and how much is in stock for a specific item. And then if we look over at my Node.js app, I can drill into Ballpens Blue and I'll see description, how much is in stock, and the cost of that item. But let's say my business is expanding and I need to add more details about each office supply item to make sure I can keep track of them. And because of this, the vsam file that the Inquire single copybook uses has been updated with new data. And if we look here, we can see I have this on order field set up on my Node.js app that's supposed to show how many pens are being ordered, but there's no data being read into it. And that's because the COBOL application has this data, but my copybook doesn't have the fields defined for them yet. So I need to go back to my COBOL copybook that is used to create the Inquire single service, then consumed by my Node.js app, and add an on order field in there. So I'll add that field, save it, stage that copybook for commit, add a commit message, added on single order field to the Inquire single copybook. I'll now commit and push that up to my GitHub repository, and that was successful. So now I can go to my Jenkins server where I have the automated pipeline set up to recreate, redeploy, and retest my Inquire single service after I've updated that copybook it uses. I've also set up this pipeline to start automatically when a change is pushed to my GitHub repo, which makes sure my COBOL copybooks in ZOS and my ZOS Connect services stay consistent with any of the changes that I've made. The first few steps, as you can see, do take a while to run, and that's because Jenkins and DBB both use Java, which runs pretty slowly on a ZD&T system. But on a regular system, these should run a lot faster. Alright, so the first step is using the Rocket Git port on ZOS to check out my GitHub repo to HFS on my ZD&T system, which includes that copybook I just edited and pushed up to my GitHub repo. So now there will be my updated Git repo in HFS on my ZOS system. So we'll fast forward a bit. Then the pipeline will take that copybook I pushed to my GitHub repo, then pulled into HFS, and add it to the correct PDS member using a DBB and Groovy script. So this is the short script you saw in my Jenkins file earlier. So with that one simple line of script, DBB takes that copybook from HFS and automatically copies it over to my PDS member in ZOS. What that means is I can store my copybooks in an open source Git repo while making sure they stay consistent on my ZOS system. So every time I change a copybook in this Git repo and push it up to GitHub or any other Git SCM of my choice, that copybook will automatically be updated in the PDS member in ZOS. Just makes it easier to store my code and my programs in Git because I can access them on ZOS or in ZOS. All right, next step. Oops. Again, in this step, we're using the Groovy scripts with DBB to rebuild my COBOL catalog manager program that reads the copybook I just edited. It'll go through Groovy build scripts, build my program, and create a build report once it's finished. DBB is also able to see what source members have been edited and will only build what is needed, in this case just the COBOL Catalog Manager program. So this saves me a step of having to go in and manually rebuild my COBOL program in ZOS. This pipeline will then check out my GitHub repo to OpenShift and use the ZOS Connect build toolkit to update the Inquire Single Service archive file with the new field, and then also update it to a new version of the service. Then it'll check, then it'll check whether that service is already deployed on the ZOS Connect server. If that service is not deployed, it will skip to the next step to deploy it. And if the service is already deployed on the server, then it will stop that service, delete it, then go to the next step to deploy it. And in this case, the service is already deployed, so it needs to stop the service and update it. All right, and now this is the step that'll deploy the updated Inquire Single Service archive file to the ZOS Connect server, and it uses curl commands to put that service archive file on the server. Next, the pipeline will again use curl commands to test that the services that are deployed on the server are working. We'll also test that the on single order field was successfully added to the Inquire Single Service archive file. And finally, the pipeline will push the updated Inquire Single Service back up to GitHub. And the pipeline was successful, which means the service was successfully recreated with the new field, updated on ZOS and on the ZOS Connect server, and tested to make sure it's working properly. All right, so let's take a look back at all the steps needed to recreate, redeploy, and retest that service. On this timeline, the light blue shows what we had to do manually, and the black shows what we automated in Jenkins. So all we had to do was make the copybook change and push those changes to GitHub. Then Jenkins saw that someone pushed new code up to the GitHub repo, So it started up the pipeline and finished the rest of the steps to update the z/OS Connect service. Alright, so now that I've successfully updated my service archive file, I'll need to pull those changes into my IDZ workspace so I can do the manual step of API mapping. So I'll do a git pull, which will merge my local Git repository with the GitHub repository to get those changes to the Inquire single service. I'll then go into my catalog API folder and select the configuration file. I'll first want to update the API version here. Then for the API path that gets details about a specific office supply item, I'll select the updated Inquire single service. And I'll get a warning telling me about the on single order field I added, which is fine. Then I'll open the response API mappings for the Inquire single path, which contains the fields that will be returned after making a call to the catalog API in that path. And we want to make sure the on single order field will be made available. And you can see that it was added here, so it will be returned when we make a call to this API. We could make some changes to response mappings, but we'll just leave it as is. So now we can just commit and push the JSON mappings to GitHub. And it was all good. So if we take a look back at our timeline, these are the manual steps we had to go through right there. We had to pull our files that changed Inquire single service archive file from GitHub into IDZ. Then we selected that Inquire single service archive file, looked at the API request and response mappings. We could have made changes, but we just left it as is. And then we pushed that JSON mappings back up to GitHub. Alright, so now that we've updated my Inquire single service and saved my catalog API request and response mapping, we can start up my Jenkins pipeline that will now automate the process of updating, deploying, and testing the new version of the z/OS Connect catalog API. So first, it'll check out the code from GitHub to get the updated API mapping. It'll then use the z/OS Connect build toolkit to create the API archive file, which is the file that describes the configuration of the API. Then it'll check whether that API is already deployed on the z/OS Connect server. If that API is not deployed, it'll skip to the next step to deploy it. But if the API is already deployed on the server, then it will stop that API, delete it, then go to the next step to deploy it. And in this case, the catalog API was already on the z/OS Connect server, so then it'll deploy my updated catalog API to the z/OS Connect server using a curl command. Zoom past this a bit. Then, using curl commands again, the pipeline will test that the catalog API that we just deployed is up and responding on the z/OS Connect server, and checks that the on single order field is returning values. Then it will push the updated version of the API along with the output of the test to my GitHub repo. And then finally rebuild and redeploy my Node.js eGUI application on my OpenShift cluster. This is a good example of how you can have some consistency with your DevOps processes, because you can integrate the building and deploying of your z/OS Connect artifacts with building and deploying your non-mainframe applications, like a Node.js app, all just in one pipeline. Fast forward to the end. So this pipeline was successful, which means the catalog API was successfully updated with the Inquire single service and mapping configuration, put on the z/OS Connect server, and tested to make sure it's working properly. So going back to our timeline, these are the last automated steps we just did in Jenkins to recreate the catalog API and test that it's working properly. And at this point, we've successfully updated, deployed, and tested our ZOS Connect Inquire single service and the catalog API that uses that service using an automated Jenkins pipeline to run the steps in black. And now we can take a look to see if my Node.js eGUI app was able to pick up the onSingleOrder field that I added to my ZOS Connect catalog API. So we'll do a refresh, see if it picked up the changes, and yep, it was able to consume the onSingleOrder field from my ZOS Connect REST API, which accesses that backend Kix COBOL application. So to review everything we've done, these are the 15 steps I originally had to manually go through whenever I wanted to update my COBOL copybook that my ZOS Connect services and API use. But by automating the process with Jenkins, Git, DBB, and IDZ, I can cut that down to just 5 manual steps. Alright, so what are all the benefits of using Jenkins, Git, IDZ, and DBB in a pipeline with your ZOS Connect projects? First, it'll end up saving you a lot of time because you can automate all those manual steps while also keeping the process of updating, deploying, and testing your ZOS Connect services and APIs consistent because it's always going through that same structured pipeline. And then since the ZOS Connect project is stored in a Git repo, you can easily organize your project and access it through a Git port on ZOS whenever you need to, which allows you to use DBB to automatically build your COBOL program if you do make any changes to the copybook it uses. And then lastly, you can integrate your ZOS Connect projects with other DevOps processes that might be running in Jenkins, like how we rebuilt and redeployed our Node.js app in our ZOS Connect API pipeline. So that Node.js pipeline could have already existed, and you can just plug your ZOS Connect build, deploy, and test steps right into it. So overall, just a few ways this ZOS Connect pipeline can make life as a developer a little easier. Alright, so that concludes my video, and thank you for watching.